Okay, Taylor, I'm just going to do the other charts for you so that you have the acceleration and the slope, which is the same thing for all of these guys so that we're on the same page there. And then I'm going to have you call me so that we can decide whether or not we've done it right. Okay, so now that I'm seeing these numbers correctly, I'll do this one correctly for you as opposed to how I did the first one. Okay. So we're going to get 6, 15, 27, 36, and 47, I think, if my eyes are doing it right this time. So again, let's do our slope, all right? Oh, sorry, I put those in the wrong column. That should be velocity. Just talking about my bad eyes. All right, here's slope, acceleration. So if we do the first one, it's 15 minus 6 over 0.1, because it's 0.2 minus 0.1. So that's 9 over 0.1, so that's 90 centimeters per second squared. Sorry, the things aren't coming out very good on the screen here. So if we do it again, we get 27 minus 12, or 12 over 0.1, so that's 120 centimeters per second squared. The next one is going to be 9 over 0.1, which is 90 again. And the last one looks like it's 11 over 0.1 for these guys. And that's 110 centimeters per second squared. So again, what I'm seeing is a constant slope. I know these numbers are not the same, but again, they're sort of in that average range, and it's enough. Given a 0.1 second time difference, it's enough for me to say that there's just some error involved here in the measurement, and that we really are looking at an average slope of around 100 centimeters per second squared for these guys. So I'm thinking that the slope the slope is constant. It's the curve. You'll have a curve for the first one. Oh, I don't know. No, because, yeah, your slope is constant. Your slope's not changing. So this has got to be a line of best fit, not a curve of best fit. Okay? So for 3, I'm just going to do the acceleration since I've done such a poor job of the charts up above there. So the first one's going to be 19 minus 12 over the 0.1. So that's going to give us 7 divided by 0.1, or 70 centimeters per second squared. The next one's, I'm not looking at this very well, sorry. I'm going to call it, because I'm not sure if I'm reading this correctly. On my screen here, it looks like 29 here and 19 here, and I'm not sure. See if I can work that out a different way from what I'm seeing. I'm not sure if I can do that or not. I don't think I can. I'm going to assume that says 29 minus 19 over 0.1 for the next two ones, which would give you 9 over 0.1, which would be 90 centimeters per second squared. And then the next one, I'm going to call it at 40 minus 29. I could be wrong, and if I am, you'll have to fix my calculations. Okay, so that's centimeters per second squared. And then the last one, I think, is 54 minus 40, and so the last one is 14 over 0.1, which is 140 centimeters per second squared. Now, this one looks like it is going up, but just because all we're changing is the ramp angle, I'm kind of suspicious here that maybe this one shouldn't be going up as a curve, because I don't know, these are going up by, like, your acceleration is increasing. It's not a constant, so your slope is actually increasing by a significant amount here each time. And so your slope is changing, and I wouldn't make a case here for it to be an average slope or average acceleration like we did in the first and the second one. Because here, at least, you know, like for these numbers, it was going up and then going back down again. And so it looked like maybe it was supposed to be constant. It's just the error that's making that go up and down a bit. Here, for this question, it's going up and down, or it's going up, 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 up. So maybe something different's happening there, but it shouldn't be because all you're changing is the angle. Let me go to the next page. Okay, so on this page, I thought I'd save you the trouble of listening to me having to work them all out, so I just wrote them out for you. So for question 4, there's the 4 accelerations going from the top to the bottom of your chart. And again, this one's wonky, right? But it's like, I don't know about this one here. That one just might be a measurement mistake. Everything from 80 up to 240, and then sort of the halfway point would be in the 150 range. So I'm kind of thinking that that should be the average slope there. The number 5, same thing, like you're really, really zeroing in on 180 centimeters per second squared there. So your acceleration seems to be increasing with your increased angle of inclination each time. I didn't work out the 6th one. I'll just leave that up to you, I guess. But it seems like your acceleration is increasing with your increased angle. And I really think my spidey sense is telling me that your acceleration should be a constant. So I don't know if maybe you should average all of these and just make an average acceleration for each one of these charts. And then you can compare average acceleration per angle and see if there's a relationship there. Like if you go up by, you know, if you go up by 10 degrees, does your acceleration go up by, you know, 10 centimeters per second squared or something like that? That's the relationship I would be looking for, and I think what I would do is for each chart use an average acceleration or an average slope. But your slope is definitely going to be linear, and I think your graph is supposed to be linear also. So I think you're looking for a line of best fit and not a curve of best fit. If you want to send me a picture of your graphs, I can verify that for you. The other thing that we could do is feed these into some graphing software, which I may do for you and just send you the graphs, and then we can talk more about that.